Hello friends, today's lecture is on standing waves. You know it very well that whenever an EM wave is incident from one media to the another media, some part of it will be transmitted and some part will get reflected back. Now, when these two types of waves are present in a single medium, that is medium 1, then they will form a standing wave. And okay, so assume that as a special case, that medium 1 as a perfect dielectric, that is sigma 1 is equals to 0, and medium 2 as a perfect conductor. This will gives you sigma 2 approximately equals to infinite. So this term will give rise to intrinsic impedance of medium 2 as equals to 0. So this gives rise to another concept, that rho for this combination, that is this combination, will be equals to -1 and transmission coefficient tau will be equals to 0 in this case. Okay, so it means that when such combination is there, that medium 1 is a perfect dielectric and medium 2 is a perfect conductor, then there will be no transmitted wave exist and only the incident wave and the reflected wave will be exist in medium 2, that will form a standing wave in medium 1. Okay, and if we analyze it, then we will get that E1s phasor part of electric field is equal to, that is EIS incident wave phasor part plus the reflected wave phasor part, and this will be equals to EI naught e raised to power minus gamma 1z plus ER naught e raised to power gamma 1z a x. But R is actually -1 is equals to ER naught divided by EI naught, and sigma 1 is equals to 0. This will gives rise to another concept, that is alpha 1 is equals to 0 and gamma 1 will be a beta 1. So we will have E1s is equals to EI naught times e raised to power minus j beta 1z minus e raised to power j beta 1z ax, and this will give rise to the final value, that is minus j2 sine of beta 1z ax with multiplication of E I naught. Okay. That is, if we write the complete wave for E, that is E1ZT, then it is a real function of E1S e raised to power j omega t, and this will gives rise to 2 ei naught sine of beta 1 z sine of omega t a x. Okay. In the similar way, we can also represent h, that is 2 ei naught divided by beta 1 cos of beta 1 z cos of omega t a y. Okay, this proves that medium will consist only the standing wave with incident and reflected wave as a combination. Okay, a pair in which we consider EM wave propagation from free space to a good conductor. That is, EM wave is incident from a free space in this direction into a good conductor, that is this one. Now, medium 1 is a free space here, so this means that alpha 1 will be 0 and sigma 1 will be 0, because due to the sigma 1 of this medium 1 is 0, this gives rise to alpha 1 equals to 0. Similarly, in this case, for medium 2, as it is a good conductor, its conductivity is very high. It means its alpha 2 is not equal to 0. It means there will be some attenuation in case of medium 2, that is a good conductor here. Okay, so whenever EM wave travels from free space to a good conductor, it starts attenuation and gets attenuated until it's completely diminished or vanished. So we can say that in a good conductor, the EM wave will vanish very fastly. Okay. This gives rise to the concept that good conductors cannot allow to pass EM waves. That is, EM waves are not present in good conductors. And this another special case in which wave is incident from one lossless media to the another lossless media, and with the condition that sigma 1, because in case of lossless media conductivity will be 0, sigma 1 is equals to sigma 2 is equals to 0. This gives rise to the another concept, that is intrinsic impedance of these two medias will be real, and the reflection coefficient R and tau, transmission coefficient tau, will be also real. So in this case, see this diagram here. In this case, this black line is your incident wave and your red line is your reflected wave, and your blue line is your standing wave, whereas your this part that is in medium 2, it is your transmitted wave. Now, due to this reason, because we have real quantities with eta 1 and eta 2, this gives that rho are real. It means if we again write E1S, this gives rise to this equation, that is Ei naught e raised to power minus gamma 1 z plus e r naught e raised to power gamma 1 z ax, or this will be equal to e I naught e raised to power minus j beta 1 z plus e r naught e raised to power j beta 1 z ax, or if we write these two quantities, reflection coefficient quantity with in terms of rho, that is r is equals to e r naught divided by e I naught, then we can say that this becomes e I naught e raised to power j beta 1 z plus rho times of e I naught e raised to power j beta 1 z ax. It means you can see here that the incident wave has maximum amplitude e I naught, whereas the reflected wave has maximum amplitude r times e I naught. It means e I naught is not equal to e r naught, and this is clearly shown here in this case. So that the wave will have maximum and minimum values at in medium 1. So you can have location of E1 max in medium 1. Okay, in medium 1 the location of E max will be given by minus beta 1 z max is equals to n pi, or z max is equals to minus n pi by beta 1, that is equals to minus n lambda 1 divided by 2. Okay, that is this one. This minus sign is due to the reason that we are measuring the location of maxima and minima in region 1 that exists towards minus z direction. So here E1 minimum location is given by minus beta 1 z minimum is equals to 2n plus 1 pi, or z minimum is equals to 2n plus 1 pi with a minus sign here divided by beta 1, that will be equals to minus 2n plus 1 by 4 lambda 1. Okay. Now note that at location of E1 max, H1 will be minimum, or vice versa. second point. Second point is that reflection coefficient for E will be equal to the negative of the reflection coefficient of H. This is due to the reason that reflection coefficient of H is equal to minus HR naught divided by HI naught. And if we convert this into E, then we can have ER naught divided by EI naught. Okay, because eta of these two quantities will cancel out. Okay, thanks for watching. Now, for eta 2 less than eta 1, this reflection coefficient R will be negative, and the change occurs only here that location of E1 max and E1 minimum are interchanged. Study what is standing wave ratio, that is denoted by S. Standing wave ratio S is actually the ratio of E1 max to the E1 minimum, or this can also be calculated in terms of H1 max divided by H1 minimum, and this will be equal to 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient. Okay, so you can also write magnitude of reflection coefficient as S minus 1 divided by S plus 1. Now, if we are measuring S in dB, then this will be equal to 20 log to the base 10 of S. Okay, this is your dB scale. So here it is important to note that we have to find out the magnitude of the reflection coefficient to calculate S. Okay, thanks for watching this video.